So I thought today we'd do a quick tear down, cleanup and servicing of this little resistor substitution box. It's a Lafayette model 99-5021. It looks like a decent little switch box. This came again from an estate sale. I'm an ex-Boeing engineer. And let's just go ahead and dive right in. And it's actually a flat and not a set screw, so let me find the appropriate screwdriver to remove the chicken heads from it. I can see the flat in there. There it is. It's interesting that I can't feel the, there it is, the flat on those. And we'll go ahead and remove the screws. And obviously not going to be that screwdriver. Let's see if this one fits. Well, it's got this elastic on it, and I'm not sure why it has it. I guess it's just silicone. See here if I can get it to peel away. Not sure what this was used for on it. Certainly it didn't seal it enough to make it explosion proof. My first thought that it was used to glue it to something, but I'm not convinced that's the case either. Where's my X-Acto? Too many tools. This one's got a broken blade on it. I should be able to use it to peel most of that away. Feels like there's another screw over on this end. It must be, yeah. It still had a bond down in there. So let's see if we can get the back to come off. It was tighter than I would have expected. Wow. Somebody torqued those very tight. I don't think these need to come off. to get the back off, but I intended to pull them off so I could clean well underneath them. Oh, I think I see what's going on. This will be interesting to get apart. There's a little indent in the sheet metal here, and then there's an ear that's folded back, and that indent is catching into where that little ear is folded back. Okay, that release that side. See if I can get it to release this side. Well, there's two nice little resistor packs here. I'm going to go ahead and remove the switch. Orientation to put it back in will be pretty obvious with where the switch sits. Debating whether to, well, it's a really lousy solder joint on both of those. I'm going to go ahead and release the leads so we can get it all the way down to the sheet metal. Should remove the resistor and rotary switch bundle. I'll go ahead and untie the knot here so I can pull the leads out and get it down to just the skins. Little insulation pad. As you can see, it's just a rotary switch. No surprise there, with what appear to be wire wound resistors. I'm guessing these are wire wound. I wonder if they're precision resistors. I'm not seeing tolerance written on anybody. I doubt they're precision. They are an interesting form factor. So I will get some cleanser here in a second, and we will clean off the skins as best we can. Problem here is if I cut too deep, I'll take off paint. I don't really want to take off the paint. It's not critical I get all of this off. Then let me get some cleaner and a paper towel, and we'll clean up the metal. So I've mentioned it before. I'll mention it again here. I find that Windex does a pretty good job just cleaning this, just normal usage, dirt and grime off. Doesn't take a lot. Give it kind of just a bit of a scrub down here. I'm going to go ahead and remove that grommet as well. Of something stuck on there. I probably should have tried a little bit of the Windex ahead of time, although I was confident it wouldn't knock the silk screen off, and of course it didn't. But always be careful when you're using chemicals around this kind of stuff, because sometimes it'll knock paint off or knock silk screen off that you just don't expect to be removed, and that's a little piece of I don't know what caught in the paint there, but that's fine. I don't expect it to look like new, but I do expect it to look a lot better than it did with kind of this cleanup. So you can already see that the face looks much nicer. I mean, that's clean enough now. I don't mind touching it. It was pretty dirty before. Just grime and mess, and the backside isn't so dirty, but go ahead and give it a good wipe down as well. The knobs are rather nasty. Good. Wipe down here as best I can. That's already markedly better. Again, it was just kind of covered in, you know, who knows how many decades of just grime and dirt. Fingers have touched it and left oil behind, and that attracts the dirt. I don't know if you can see the difference or not between the cleaned up chicken head and the dirty one up here on top. The white line's actually white again. You know, it's not perfect. I think I need to do a little bit of scrubbing there. Yeah, that got the rest of that off there. What I didn't pay attention to, and probably should have, is I took those off assuming there was a flat on the rotary switches, which there isn't. So I can see on this one where the set screw contacted on it, and I can see on that one where it did, so we can get them close. It probably would have been smart to have checked that, but I didn't. No big deal. We can rotate the switches, get them into a known position, and get the heads on. So that's much better. I'm going to go ahead and do a little bit of wipe down around the edges of this switch. It was exposed through the top of the case there. Just brighten it up a bit. Not getting Windex down into the outside of the switch assembly itself. We'll get it with some deoxit, but just kind of wipe out here what's dropped down inside. We have this little insulating piece of cardboard here. See, let me wipe this down on the inside. Some of the Windex actually leaked down through the holes, and a little bit of the dirt transferred to the inside. And although you can't see it while I'm in there, I'd like to clean it up. Inside of the bottom of the case here is a little bit dirty. It's had stuff just kind of settle down in there. And again, not that it's critical, but I'll know I took care of it. So, reassembly should be pretty straightforward. So then step back and put the grommet in first. It'll be a little easier without everything in the way. The grommet's still nice and rubbery, which is good, so it'll continue to provide insulation between the sheet metal, the hole in the sheet metal. And the units. Don't worry about precision alignment of those later. Just getting these started enough to keep them from falling out. The 2 screws for the slide switch. Get it into position. Do an inspection of the leads here. looking for nicks in the insulation or bare spots or melding like a soldering pencil's touched it. I don't see anything, which is nice. And we'll go ahead and give each of these a wipe down as well. Just because I can while I'm here, might as well clean it up. Wipe off the rubber boot. You can see the streaks in there that came off of the wire as I pulled it through. As I pull the wire through, I'm rotating it as well. And just kind of wipe down the rubber boot over the alligator clip, just because it's a little dirty. Alligator clip has seen better days. It's just, well, most of what I'm seeing is wiping off. There's a small amount of surface rust on one side of it. Just trying to walk the rubber boot back a bit. This one's in better shape. Anyhow, I'm happy with that. Let's feed the leads back through. Tie the strain relief knot back into them. Remember which lead was wrapped around which, not that it matters. It's this way. Apply a little fresh solder to the places I'm going to tack those wires back on. Re-tin the wires as well. No reason not to. Black lead was tacked on up here. Red lead was tacked on to the center position on this little slide switch. Go to the low range, power up my own meter. Ohms. It's currently setting at 10.77 k ohms, which is actually a range beyond what 5, 4, what this offset is. That's rather weird. I think we've switched all the way around in one direction here. 1.468K, that just doesn't make any sense to me. We've got a good 0. I'm a little confused here. What I'm reading on the ohm meter is completely inconsistent with what I think this should be in the range of. So I'm going to get in here and actually look. Might have a bad lead. It's measuring 1.9 meg. I'm not sure it's measuring 1.9 meg. The grounds are common. It should be fine. When it's a resistor substitution box, this shouldn't be giving me this kind of grief. To that side, we're looking at 1.5K. And there's a 1.5K ohm range on here, so possibly that's what we're pointed at. And on the other side, we're looking at 1.9 meg. $15K, 33, 47, 1 meg. That one doesn't make as much sense range-wise. Just under 1.5K. Where'd that little flat screwdriver go? Up here. Thought I got a good bite, but I certainly didn't. 1K, 1.5, 0.7. These are all, well, that one's 6800. These aren't particularly close. Then I'm not expecting precision here. 220. 470 is at 491. 1K is at 1013 ohms. 1.5K is at 1469 ohms. So they're close enough. It's not a precision switch box in any sense of the word. Let me see if I can get into the slot and screw again and just a little bit of additional torque. Let's go to the high range, and that's 1.9 mag, which is, there is no 2 mag on here. See if we can find something that's a little more reasonable. Okay, that's 1 meg there, I do believe. Yep, well, I'll leave it on 470. So that's 470K. Not that this needs to be all that super accurate from the knob. So that should be 15K, it's reading 14.6, 33K, it's reading 33.4, 47K, reading 49, 100K, reading 99.3, 720, or 220K, reading 224, 470, reading 484, 1 meg, reading 991K. The 1.5 meg is reading 1.9 meg, so I think there's just something unhappy with that resistor. 2.2 meg measuring 2.19, 4.7 meg at 4.64, 6.8 meg at 5.9. It's pretty low. And the 10 meg is measuring almost 11 meg, so not particularly good. I am going to get in here. I should have done this while I had these actually removed. This was kind of stupid to wait till I had it assembled, but I can get in here and get some contact cleaner in here. Looks to me like perhaps 2 of the resistors have been damaged at some point. Yeah, it would have been smarter to do this while I had it apart. But I didn't do that. .47's measuring 45.2 ohms, 100 ohms measuring 101. You know, for most things, it is absolutely fine. Get a little shot down here on the slide switch. Go 10K and 10 meg. There's 10 meg. There's 10K, 10.7K, 10.9 meg. You know, for what it is, just an inexpensive little Lafayette resistance box, the resistor substitution box. It's fine. It's not like it's a, you know, a decade box. Let's see if I can peel some more of this off of here. And really the last step is just to get the skin back on. And it's got to be, it's going to be a little bit tricky. There that is. Oops. Just a note here, don't tighten the first screw you put it up. Actually get them all started and then come back around and tighten them. That'll help with the other screws start if there's, drilling errors or slight alignment issues. Often you'll have one screw that doesn't want to start because the two holes don't line up well. So just save yourself a bit of grief. Start all your screws and then torque them. These don't need to be dramatically tight. So there you have it. Hopefully I'm recording still when I am. So Lafayette, again the model 99521 resistor substitution box. It's much cleaner. It doesn't feel icky to touch like it did before. We've given a bit of cleaning to the switches, cleaned the case. It's a nice little addition to my bench. I don't need a resistor substitution box all that often. Of course, I've got another one sitting back here that we looked at in a previous video that is resistor and capacitance, and you can put them in series and parallel and do all kinds of fun stuff with this. Don't use it again very often, but when you need it, it's handy to have. I will add this little guy over there with that one, and I guess end this video. So anyhow, hopefully that wasn't too boring, and we'll talk soon. Bye.